on today's lesson. And what we're looking at today is simplifying complex fractions. So we have fractions in fractions. We have two different methods for doing this. Method one, if necessary, simplify the numerator and denominator by writing each as a single fraction, then divide by multiplying the numerator by the reciprocal of the denominator. And method two is multiply the top and bottom by the LCD of every fraction in the numerator and denominator, then simplify. So we have two different ways we can do this. So this first one, we're going to look at our first method, doing it by the first method first, and then we're going to do it again with the second method. Now our first method, what we need to do is get a single fraction on top and bottom. Now the numerator is already there. We have 5 over x plus 4. So it is one fraction. However, the denominator, we have 2. Yeah, I just rewrote it. Now, the first thing we need to do is get these two denominators in the bottom to become 1. And to do that, we need to be able to add the two fractions together. And in order to be able to add the two fractions together, we need the denominators to be the same. So for them to be the same, well, because we have x plus 4 and x. So what does the right side need? Well, it's just x. What is it missing? Well, it's not just plus 4. Because x plus 4 and just x are two separate terms. So the right side we need to multiply on top and bottom by x plus 4, which means the left side we need to multiply it by x to get them to be the same. Now our numerator is still going to be 5 over x plus 4. This denominator, we're going to multiply our numerator. 1 times x is just x over x times x plus 4. Plus our other numerator, we're going to do 2. Well, 2 times x is 2x. A little bit. 2 times 4 is 8. Over our x times x plus 4. Questions on this so far? Now at this point here, the denominators are the same. We have 5 over x plus 4. So since the denominators are the same in our denominator, we can add our numerators. So we'd have x plus 2x plus 8. Now we can simplify a little bit. We have 5 over x plus 4. Well, our x plus 2x is 3x plus 8 over x times x plus 4. So we have this here. Questions on how we got to this point? You're good. Now at this point here, we have 5 over x plus 4 all over 3x plus 8 over x times x plus 4. We have two fractions. Well, whenever we have a fraction, say 1 over 2, this is the same thing as saying 1 divided by 2. So here, we can rewrite this as 5 over x plus 4, and we're saying it's being divided by our 3x plus 8 over x times x plus 4. So we're actually dividing the two fractions. Okay. That's really what we're saying. Now, when we divide two fractions, to do that, we keep the first one the same. We change it from division to multiplication and flip the second expression. And at this point here, we can multiply the two together. Our numerator, 5 times x, is 5x times x plus 4. Our denominator is x plus 4 times 3x plus 8. Is there anything in common on top and bottom? X plus 4. Since we are multiplying these, we can cancel those out, leaving us with 5x over 3x plus 8. Now, since we can't factor the denominator at all, 3x and 8 do not have any like terms, so we can't simplify that out. 5x on top and 3x on bottom won't simplify because of our plus 8. So it leaves it as 5x over 3x plus 8. Questions on this here? Questions, anything we did for this one here? All right, we're going to do method 2. Same problem. Now, for method 2, we need to find the least common denominator between our three denominators. If you don't have room underneath, you can write it above it. Different method, doing the same thing again. So you should have some room under the first part. Now, we have three denominators. We have x plus 4, and x. And we want to find the least common denominator between these three expressions, x plus 4, and x. Now, when we look at these here, we have three expressions, and we need to see what the least common denominator is going to be. Okay. With our x plus 4 and x plus 4, what's the first thing we can make both of those be? Well, it'll just be what? Yeah, x plus 4. Because they're already the same. Yes? So those are already the same. But since they're only listed once in each denominator, they appears twice, but in each denominator only appears once. We only need it once, a part of the least common denominator. What else do we need for it? X. So our least common denominator for this is x plus 4 and x. Okay. Question on how we found the least common denominator. I'm going to remove this so I have a little bit of space. Now, what we're going to do is we're going to take that least common denominator and multiply top and bottom of the fraction by it. Be ready for the next step. Now what we're going to do is we're going to multiply the x times x plus 4 by each of the fractions. So for our numerator, we're going to multiply the x times x plus 4 by our 5 over x minus x plus 4. And it's going to multiply with the 5. So we'd have 5x times x plus 4 over x plus 4. Questions on the numerator of this here. Now the denominator, we're going to do the same thing. Our x times x plus 4 is going to multiply with our first fraction. And when we do this, it's going to multiply with the numerator. So we're going to have 1 times x, which is going to be x times x plus 4. Plus, we have x. We're going to do the same thing here. We're going to have our 2 times our x times x plus 4, which is 2x times x plus 4. Question on how we did this multiplication here. What's in common on top and bottom? On the numerator, we have x plus 4 and x plus 4. The denominator, in the first spot, we have x plus 4 and x plus 4. In the last one, we have x and x. And all those will simplify, leaving us with what in the numerator? Because we have the 5x. In the denominator, the first fraction reduces to just x plus 2 times x plus 4. Because here, the only thing that simplified was the x plus 4 and x plus 4. If the x were to simplify, we'd also have needed x times x plus 4, because our x and x plus 4 are 2 different terms. Any other questions on this here? Questions on how we got to this point? Now, here we do need to do some simplifying. So we have 5x. X is fine. But we have to distribute this 2. 2 times x is 2x. 2 times 4 is plus 8. X plus 2x is 3x plus 8. Is that what we got before? That's it. I feel we like the second method a little better. We're ready to look at another one. All right. So to do this by method 2, we need to figure out what we need to multiply the top and bottom of this fraction by. Well, we need. So both, yes. Because what's one thing we need to multiply top and bottom by, a part of our LCD? Because what are our expressions that we have in the denominators? Because we have x minus 2 and x, yes? Is there anything else listed in each denominator? No. We do have x minus 2 showing up twice, but it only appears in each of the individual fractions denominator once. So that means we will have to multiply top and bottom by x minus 2, but we only need it once. One's on top and bottom. Now, if one of them had been, say, 6 over x minus 2 times x minus 2, then we would need it twice. And then we'll also need the x, because it is listed as one of the denominators. We need all of the denominators to simplify. And that's why we're doing this here, this multiplication. Now again, we're going to multiply the x times x minus 2 on top and bottom. So we multiply it with our numerator fraction, our 6 times x minus 2. Well, it's just 6x times x minus 2. Because we're multiplying that with the numerator. Six times x times x minus 2. Yep. You're good? For now. But we know that those two will cancel out. Yep, that is why we're doing it by the x minus 2. If we look at the denominator, the first one we can do is our 1 times x minus 2, which is just x times x minus 2 on top over x minus 2. And again, here the x minus 2 and x minus 2 will cancel out. Then we're going to do x times x minus 2 with our 3. Well, 3 times x is times x minus 2 over x. Now, at this point here, I wouldn't distribute through. I wouldn't do the 3 times x minus 2 just in case something simplifies. Because if we did that here, we would have written in x squared minus 2x. Well, x squared minus 2x and x minus 2 wouldn't cancel out. We'd have to factor it back out. But with our 3 and x, they multiplied 3x, yes? But 3x over x, our x and x will still cancel out easily because we have x over x. That's the ones we can multiply, those monomial terms. We don't have addition and subtraction messing with it. So again, this first step, all we've done with this here is I've taken that LCD and multiplied it by each numerator. Each of the numerators, all of them. And I write it back out. Anything we have on common on top and bottom in each of the fraction individually will simplify. So the big fraction as a whole, we're not simplifying at this point. Now in the numerator, what's left? Yeah. So numerator, we have 6x, yes? And the denominator of the numerator reduces to 1. The denominator here, the first term we have left is x plus 3 times x minus 2. Because the x minus 2 didn't simplify out where our 3 is located, the second one. But we have this here. So we will indeed need to distribute the 3. It still stays 6x on top. We have x plus 3 times x is 3 times negative 2 is negative 6. Combine like terms. 6x over 4x minus 6. Now 6x won't factor. 4x and 2x can factor. Greatest common factor of 2. And if we factor it out, we're left with 2x minus. Well, the numerator and denominator simplify now. Yeah. We have 6 on top and 2 on bottom. What's 6 over 2? 6 over 2 is 3 over 1, yes? So 3 would stay in the numerator. Let's scroll down so this is not so close to the bottom of the screen. Because we'd have 3, and we still have the x on top, yes? The 2 is now 1. So we can just say it is 2x minus 3. Because we now have multiplication with that 2 and 2x minus 3, that multiplication lets us reduce the 6 and 2. The 3x and 3 that we have left over don't because of the minus, because it's 2x minus 3. Questions on this here? Because we have 3x times x minus 2 all over x, yes? Is this the same as 3x over x times x minus 2? What's 3x over x? What's x over x?
I don't know. X over x.
Anything divided by itself. Let's 2 divided by 2. X divided by x. So that is 1, so that is John telling us it's 3 times. Yep. Questions on anything else here? Yeah, it's been hit and miss for part of the day. Questions on this problem here? Are you ready for the next one? Now again, we need to find the least common denominator between 6, 3, 5, and 10. So we could multiply these together. 5 times 10 is 50. 3 times 6 is 18. You get 900, I believe. Apparently that's not open. Give it a second. Three times 6 times 5 times 10. 900. But that is not the least common denominator. It's not our least common multiple. For these here, 3 and 5 are already prime factored. Those are prime numbers. 6 is not. It would be what? 2 and 3. 10 is 5 and 2. So least common denominator, least common multiple, we're going to take the most of each of these prime factors that appears in each term. Well, 2 appears twice, yes? But in each one it only appears, we need 2 once. Let's look at 3. Well, we have 3 by itself, and here we have a 3. But each of these only appears once. 5 is the only other one, but it only appears once in each one, yes? But when we multiply these 3 together, let's get an electric green, because I had, let's pick another color, that's purple, because I had an extra 5, extra 3, and an extra 2, yes? Well, that's an extra factor of all 3. So let's see what this number is. 2 times 3 is, times 5 is 30 is the least common denominator, least common multiple. But when we added an extra factor of 2, 3, and 5, we actually added an extra factor of 30 to the entire answer. So multiplying top and bottom by 900 would work, but at the end when we're simplifying, we'd have to pull out a factor of 30 on top and bottom instead of just using 30. We're ready for our first step. Now we're going to do 30 times x, which is 30x, and it's going to be over 6, minus 30 times x. And this time it's over 3. Do the same thing in the denominator, 30 times x, 30x, and this time it's over 5, minus 30 times 7. What's 3 times 7? 210. So let's look at each one of these here. 30x over 6. 30 divided by 6. So we have 5. We still have the x, so 5x minus 30x divided by 3. 10x. So that takes care of the top. The denominator is 30x divided by 5. Oh, 30 divided by 5 is 6. We still have our x. 210 divided by 10. 21. 5x minus 10x. Negative 5x. Well, 6x and 21, we can't combine those, but can we simplify it? Can we factor it? Yeah. 6 and 21 have a common factor of? Because if I divide 6 by 3, I'm left with 21 divided by 3. 7. And 5 and 3 on the outside simplify, yes? 5 divided by 3 is what? Yep. It doesn't divide evenly, does it? Since it doesn't divide evenly, that's our answer. Stuck? I was actually a tryhard. 6, 12, 18, 24, 30, 36, 42, 48, 58, no, let's see here, 42, 48, 54, 60, yeah. Yeah. Questions on this here? Let's look at this one here. What do we need to multiply the top and bottom of this fraction by? So I'd agree with x, because we have x here in the denominator and yeah. It's just x, because 4 and 3, we do have those there, but do they have a denominator? No. So the only one we're worried about trying to get rid of is our 2 over x and 2 over x. Now we can multiply this here. Well, our 2 over x times x is, well, 2x over x minus, well, we got to distribute through. So we're still going to do 4 times x, which is, do the same in the denominator. Our 2 over x times x, 2x over x, plus x times 3 is, simplify. Well, our 2, the x over x cancels, leaving us with 2 minus 4x. Again, the denominator, x and x cancels, leaving us with 2 plus 3x. And as much as we want to, the 2 over 2 does not simplify because of our minus in the top, our 2 minus 4x, that's a single term. We can't just cross out one of its parts. And the same thing is true for our 2 plus 3x. But the numerator, 2 and 4x, has a greatest common factor of?
X. Oh, 2.
2. We can factor it out.
1 and
1 minus 2x over 2 plus 3x. Okay. Now we can see for certain nothing simplifies. So that is our final answer.
so much easier.
Is the minus 4. Because again, this and this are one term. So our 2 over x minus 4 is one whole term. Our 2x plus 3, or 2 over x plus 3 is one whole term. We can't just cross half of it out. Now if it had been multiplication instead of addition subtraction, then yes, we could do that. But the addition subtraction sticks those two together. We can't just easily cross them out. Questions on this here?
Oh my god. Never mind.
What would you need to multiply the top and the bottom of this by? We would need an x minus 3 and x plus 5.
Oh yeah, just 1 time. Okay.
Because the numerator, we have x plus 5 in its denominator, yes? So we'll need one.
Like my brain just wants to do whatever's not there in the other.
Yes. Because that is part of it. Because when we're looking at adding and subtracting two fractions, seeing what one has and what doesn't. But here, we're wanting to get rid of all three of these fractions. X minus 3, we'll get rid of the denominator in this one. And a single x plus 5 will get rid of both of these here. Now we do this multiplication. So in our numerator, indeed, it would be 3 times x minus 3 times x plus 5. And we have x plus 5. And the denominator, we can do it again. We'd have 2 times x minus 3 times x plus 5 over x minus 3 plus. We'll do our 1 times x minus 3 times x plus 5, which is, well, x minus 3 times x plus 5 over x plus 5. Questions on how we got to this point here? What cancels? So in our numerators fraction, the x plus 5 and x plus 5, one of the denominators, we have x minus 3 and x minus 3. And in the last one, we have x plus 5 and x plus 5. Those are gone. So in our numerator, what's left is 3 times x minus 3. In our denominator, we have 2 times x plus 5 plus x minus 3. Yes? Now we need to do some distributing. And the reason we distribute is because we need to be able to combine like terms. Yes? Questions?
Oh, never mind. I just wrote it wrong. Sorry.
You're good. Because we need to distribute to be able to combine like terms. Yes? Are we going to need to combine anything in the numerator? No, it's 3 times x plus 3, yes? Or sorry, not x plus, x minus 3. So I could, there's nothing wrong with multiplying the 3 times x and 3 times negative 3. But if there is something in common at the end, we'd have to factor the 3 right back out. So is there any reason to distribute the numerator? No, we'll leave it alone. But if we look at the denominator, I have x, I have numbers, I have stuff that could possibly combine. Yes? So we have to distribute this here. 2 times x is 2x. 2 times 5 is 10. plus x minus 3. Lo and behold, we do have like terms, yes? 2x and x. 2x plus x is 3x, yes? Could be that there's a like term that we could simplify out with our, and then simplify the 3 on top, yes? But before we jump to that, let's do the other ones. 10 minus 3 is 7, positive or negative? Is there a common factor on bottom? No. So it's just going to say 3x plus 7 because we can't simplify down any further. So our final answer is 3 times x minus 3 over 3x plus 7. That's it.